This is Silence Did Good. I am recording on a MacBook Pro with Algodoo and QuickTime Player, and we're going through a little bit on demoing Algodoo as a bit of a whiteboard, but also then talking about the mathematics of graphing, which includes the concept of nodes or vertices, edges or links, and then eventually faces when we get into using it for something like 3D modeling. And what we're going to go through here now is the kind of crux of it in the end, is how in fact first how this stuff is stored using a program like this. You get students that can go ahead and look beyond and behind the data. So what's great about Algodoo is it'll give you things like mass and density and things that you start covering in elementary school, but also starts to give you an ability to do other fun things that have to do with data structures of social graphs. Or if you would, any kind of graph that can be modeled out in a link node or in a network. So either a tree or a network. And so what I'll show right here is by right-clicking on top of one of the nodes, as we called it, and I probably should have modeled those as circles, and I go to the script menu, and you'll see here as I bring this up that it actually records the position of the center of gravity, actually, the position of it. And so that's the first thing very often you might be dealing with when you're going to actually use link node or graphs tied to real 3D space. The position, in this case, it's shown as an XY, but we want to really quickly, because the other program that you're going to want to expose students hopefully to is another free one called Sketchup, and that is a 3D engine. So this is a vector showing the position XY. They start to see that the brackets are there as opposed to necessarily just the parentheses that they see in math class, and you start to help them to differentiate or tie together what's happening on their phones to what they're doing in math class, or physics class, or social networking class, computer class. So there you also see generally what you're also going to have is a name, and we're going to look for that here. Body, let's see. Typically you're going to have a name attached to this, and in this case I'm not going to spend the time to look for it, but a lot of properties that are attached to that particular one here is color and area, etc. Very often there's going to be an ID. Let's see if I can get in here and click down, or a name if you would, and sometimes you got to see I'm moving that around here, probably not good. I'm going to click on that, and so you have the concept then of name and then location. The thing to look at again finally is remembering that when you're describing a location with X, Y, and Z coordinates, let's say, or just X, Y, that you need to have defined an origin. Very, very important to say this quite earlier. You're doing it by default from a long time, starting in probably 4th or 5th grade when you start doing graphs, as in graphs on a plane. However, again, the students are working in phones in 3D, they're living their lives, they're watching stuff on TV, cars are parking themselves, cars are soon driving themselves, so understanding that in fact you need to know what coordinate system you're in, and that coordinate system and how it's defined in some way, shape, or form is important. So just knowing that, putting that down and being very careful about that from the start, even though it's always going to be the same. Typically in an Algebra 1 classroom, it's an X and a Y, or an A and a B, or a north, south, east, west. Just being clear that there is an origin here. Now that this program does not show the origin, but I'm going to go ahead now, click in this next one. I'm going to right click and once go to script menu, and the reality is you see this one is positive 0.5 in the X and positive 3.69 in the Y, and so there should be a way essentially, and I think there generally is, to show the graph. And so my guess would be positive 5 my guess is the origin is right there for this. And so we'll try that. We'll try this one here. Right click, script menu, click on that, and in this case it is showing the location is minus 5.8 and plus 2.6 in the Y, which says that my guessing was not right. It's probably flipped around. In this case, which is X and which is Y. I'm going to go ahead and put a circle right there. But kind of knowing that students should know where their origin is in any one point in time. I can draw this better next time. I'm going to right click, script menu, and when I go to that, it shows position as 3. Alright, so I'm going to get out of this before and the next time in I'll more or less learn to put some. I'm going to go undo here. You want to really establish, and this is one of the downsides of this if it's not showing what is the origin. My guess is that it might be dealing with a typical computer science framework or a left-hand coordinate system where you go left and right as your first coordinate and then up and down is your second coordinate. So it's a left-hand coordinate system like on a screen, or a right-hand coordinate as on the math, and so you're going to want to establish that before you use a tool like this too much. But the crux of wanting and knowing that you can then, and I'm going to finish up with that, account for the position, if you would, of coordinate 0. Turn the grid off here. Basically, if you're going to describe the position of the nodes, you can draw a matrix right for any one node. Would be its X, its Y, its Z, and then realistically very often we're going to want to learn to put a 1 here. We'll talk about that later. A chaser, if you would, when we start going from 3 to 3 to 4 by 4. So if you're doing math class with X, Y, and Z, if you're using the 3 by 3 is required in the Common Core, but then the reality that sometimes you're going to want to, for other reasons, kind of fill these matrices with either 1s or 0s depending on the case. So that would be, this would be in the case of X0, the X position of the 0 node, the Y position of the 0 node, and the Z position of the 0 node. And then if you wanted another node, you would have the X, right, of the first node, the Y of the first node, and the Z of the first node. And once again, always carrying around this extra 1 as a chaser for points, and you'll see later on the 0 if it's a vector. Now in this case, I'll do the third one, X3. I'm just using this again, demoing the whiteboard capabilities. I'm working on a trackpad here, so it's actually not as bad as I would hope or think. Try it again. This is Y. That was 3, this should have been 2. And Z, 2. And then of course the 1 here. Now, what you'll eventually do is you may want to add to this base matrix to maybe keep track of the name, but in this case, if we start counting at 0, our name is implied by the location. So column 0, column 1, and column 2. Having students that learn that sometimes when you're naming things or counting, you count starting at 0, and sometimes at 1, or whatever, is an important thing. So this all said, I've laid out now what essentially it is the location matrix, location of points for the nodes, without adding a name to them, which you may or may not, probably don't want to do in math class to start, but you do want to get people used to how matrices are used for more things than basically the, I'm going to say, generally bland and indecipherable problems that they're exposed to, uh, as opposed to the social network graph that they're doing when they're doing Instagram, Twitter, whatever the case would be. So I'm going to once again stop this and file, save it as a demo 2, but I'll just stop the recording as we are, and we'll touch back with this when we start looking at how we now keep track of the links, or the edges if you would, and then the faces, and we may or may not be in Algodoo when we do that.